Hello, today we will talk about types of systems of equations we may have in two dimensions, two variables. So let's summarize what we have done with graphing, addition, and substitution method. And can we give some names to different types of systems? Okay. Now, the first word that you can use is independent systems. That means, since we are talking about two dimensions, you have and linear equations. So this is what we have. We have two separate pictures. So since we are doing or graphs, since we are doing linear equations, we are talking about two different lines. So an independent system will look something like that. Here's one line, and here's another line. That would be an independent system. Okay? Two different lines. They may crisscross, they may not crisscross. But nevertheless, two different lines. If you draw your lines when you're given the equations, that system is going to be called an independent system. Let's talk about dependent systems. That is only one picture. In other words, you have two equations on only one picture or one graph. Two equations, but the second equation is exactly the first equation, but kind of like this guy. So if you have one equation and its picture is like that, L1. The second equation, when you work it out, it goes on top of the first. So the L1 and L2 are actually the same exact equation, but disguised. And when you draw them, they are on top of each other. That kind of system is called a dependent system. Okay, a consistent system. A consistent system is a system where you end up with one unique solution. Here's one line. Here's another line. They will always crisscross, and you are going to have one unique solution. A consistent system is a system that has a solution. Now remember, in the past examples, I used to have a situation where I have one line like a dependent system, the other one is on top of it. That one also has solutions, just infinitely many. So a consistent system is going to have only one solution or infinitely many solutions. But nevertheless, it's going to have at least one solution. So a consistent system is a system that has at least one solution. So it can be infinitely many or one, but it has a solution. Inconsistent systems. Those are the systems that have no solutions. How can that happen? Let's say L1. The only way that can happen is if you have an L2, and it's in no case is going to get close to L1. So they are parallel lines. If we are talking about a linear system, they will never touch. They will always be away from each other. That's an inconsistent system. Well, let's try to do a couple of things algebraically. Let's look at solve y equals x and y equals negative x. I can solve it with a graph if I want. I know that y equals x looks like that, y equals negative x looks like that. I know my solution is 0, 0. Well, let's try to do the same problem with addition method, for example. Y equals x, y equals negative x. Let's move x to the left. Negative x plus y equals 0. This one is plus x plus y equals 0. So when I have this situation, add them up, I'll have the x's go 2y equals 0, y equals 0. And put that back in here, I will also get x equals 0. So 0, 0. What does that mean? This kind of system has one solution, So it's consistent. And I had two lines, two separate lines, right? So they are independent. So it's an independent, consistent system with one solution. Let's look at the other one. Y equals x plus 1. Y equals x looks like this. Y equals x plus 1 looks like this. They are parallel. I know there is no solution, but let me see how I can do that. Y equals x plus 1. Let's use the substitution method for that. So I'm going to put x in here. Let's solve that. X equals x plus 1. And subtract x from both sides. I'm going to end up with 0 equals 1. That is not happening. Left and right don't match. What does that mean? No solution. So what kind of system are we talking about? I had two different lines, so they are independent since I have two different lines. But the problem is I had no solution. In a system that has no solution, it is called inconsistent. Very good. Let's do two more. Y equals x and y equals 2y minus 2x equals 0. So let me do this right here. I'll move the 2x to the right. 2y equals 2x. All right. Let's use addition method. So I have negative 2y equals negative 2x. 2y equals 2x. 0 equals 0 when I add them up. What does that mean? You have infinitely many solutions. All right. And actually, I did not have two lines, but I had one line. What is that? That's a dependent system. And since it had infinitely many solutions, it's also consistent. Very good. Let's do the last one. Actually, those two graphs were on top of each other. The first one and the second one is on top of the first one. So they touch each other at infinitely many points. Dependent, consistent. All right, let's look at y equals 2x. I'll do that with substitution. Y equals 2x. Y equals negative 3x plus 1. So let's put that 2x in here and solve. 2x equals negative 3x plus 1. Let's move 3x to the left. I have 5x equals 1. X equals 1/5. Now let's take that x and put it where y is. Y equals 2x or y equals 1/5, which is 2/5. So I have one solution. My solution is 1/5, 2/5. All right, since I have a solution, the system is consistent. And since I have two different lines that are separate from each other, this one is independent as well. So I have a consistent, independent system.